Hello, I'm Shaun Thomas, and today I'm going to discuss my contributions to 3.3-1. Um, so overall, what I did was I helped create the shadow logic to generate shadows from a light source. Uh, so the way the code works is if you run this, it should render two pots with a light source. The light source isn't like a physical thing you can see, but it's used to calculate the color pixels should be to simulate a shadow from the first pot onto the second teapot. So while this is running, I'm going to go over my code. So for this first line is, like I said, the light position. It's not like a physical thing you can see. It's just an area in the three-dimensional space that is used to calculate basically rays of light onto the scene. This red code is one of my teammates' code. So here's just another vector 3 function I added. It's called add. And basically it sums up all the values of the x, y, and z positions of the vector. And then another vector 3 function, length, which basically squares all of the values and then takes the square root of it, similar to the Pythagorean function, but for 3 dimensions. And then here's more teammate code. And then here's the shadow factor, which is taken from the calculate shadow function that I worked on. And essentially the shadow factor determines how much shadow color should be added to a pixel. So as you can see here for RGB, it takes the red, green, and blue value, and then it implements the shadow factor variable into it as well to determine how much shadow should be applied to like a specific area. And so here's the calculate shadow function. So what this first part of the code does essentially is it calculates a vector from the surface point of the light source, and then it essentially just gets how far away it is from the light. And then the vector normalized into a length so that it can be used to calculate the distance and direction that the shadow ray is, so that I can determine if there's any light or if it's getting blocked or if the light's getting blocked in this area. So for the next part, so essentially this part creates a shadow ray that points from the surface toward the light, and then it will go through every single triangle in the scene to see if that triangle, if it blocks the shadow ray in the intersection, so that it can determine if there should be a shadow here or not. And then finally this part, um, so essentially what it happens is if something is blocking the light, then it will return 0.3, which is just basically no shadow. And then if it does block it, then it does calculations to determine what amount of shadow should be there and also the area that the shadow should be. Um, and then that's all the code. So then, as you can see here, this took about 2.5 minutes, and now this should be here if I open it up in Explorer. Um, so as you can see here, there's shadows here and down here and over here as well. And the light source is off camera. So that's essentially 3.3-1 and my team's work on the assignment.